Thank you all for coming. This title of the session is Secure Content Delivery Using Amazon CloudFront. My name is Alex Dunlap. I'm the general manager for CloudFront. I've got Matthew Baldwin here with me. Matthew is a senior software development engineer on the CloudFront team. I want to start with just a thought from Andy's keynote yesterday. He talked a little bit about ands and ors, and I won't get quite exactly the quote right, but he was basically saying traditionally folks have been asked to make trade-offs between one of two things. You know, do you want this or that? And the premise of AWS and what we're doing often means the ability to say and. I want A and B, not A or B. And with that in mind, today we're going to talk about using CloudFront, a product that's usually considered something that helps make sites faster, to also help make those sites more secure. So rather than choosing between fast or secure, what I hope you leave here today with is an understanding how to make something fast and secure. We're going to talk briefly about why security matters. We're going to talk about how we think about security in terms of the key aspects and the things that make it up. We'll talk in a lot of detail around how CloudFront can help, and hopefully you'll walk away with some specific best practices about how to make your content more secure. This is a 200-level session, so it's not going to be we're not going to be going through detailed code examples, but it does assume some amount of knowledge of CloudFront and content delivery. Why does security matter? A lot of this should be fairly obvious, but I think it's the right place to start. Security matters because we're often, when we're putting websites online, we're talking about maintaining customer trust. We're talking about maintaining regulatory compliance. We're talking maintaining the integrity or the privacy of customers' personal information. We don't think that you should have to give those things up just to make a site that performs faster, a site that scales better, all of the benefits that you get from using a CDN like CloudFront. We don't believe that should come at the expense of any of these three things. In general, AWS thinks of security in three different areas. The first is the security of our infrastructure. This is how we secure the facilities and the servers and all the things that make up our services. The second is the services security. These are the security options and features that are available to you as the customer. And the third is the application security, things you do in your application itself. Inherently, the cloud is a shared security model. So it's a shared responsibility. We take certain pieces of responsibility. You take certain pieces of responsibility. So we'll go through and kind of use this framework to talk about CloudFront and talk about how we secure our infrastructure, how we secure our services, the CloudFront service, what options we make available to you, and things you can do in your application to make your content delivery more secure. This is going to be the device I'm going to use. On the, I guess, one end of the screen, you'll see things that CloudFront does automatically. We're going to signal that with a DNA logo. Basically, these are things that we're just going to do automatically on your behalf, things you don't need to think about, but security that you get just by the virtue of using CloudFront. The user icon there will represent things that you need to do, things that you can do with your application or your configuration of CloudFront features in order to make your content delivery more secure. And it's the sum of those two things together that really will represent secured content delivery. So let's start with the infrastructure. And I'm not going to go into a whole lot of detail here, but want to talk briefly about some of the things that we do on the hardware side, on the facility side, in order to secure our physical infrastructure. It starts with some basic stuff. It starts by limiting access to our facilities, putting our facilities into nondescript locations, making sure that there is professional security staff available there. I think I'm on the next slide. And then it goes on to things that we do in terms of how Amazon employees are able to interact with our infrastructure. So one of the things that we do is every employee, when they're deploying software or otherwise interacting with our hosts, goes through multiple layers of network security, two-factor authentication, in order to access the servers themselves, the code themselves. We have multiple layers of encryption, separation that enhances our containment, basically understanding who is able to access what and make sure they're not able to access more than they're entitled to. And then finally, rigorous logging, making sure we know who has done what to our services, making sure every deployment has been tracked and authorized and was intended. The result of all of this, this is a fairly new development for CloudFront. CloudFront was included in our last PCI certification or audit. So that was very exciting. That's just something that came out at the beginning of the third quarter. More interesting, I think, and the focus of this talk today will be about security, services security, and application security. So let me start with the first of those, which is services security. These are the options and features that you can configure as part of CloudFront. CloudFront can protect data in transit. We have a variety of mechanisms that do that. Let's talk about what that means. At the core, the core method we have to do this is HTTPS. And we have options that will allow CloudFront to encrypt data using HTTPS between our edge location and the origin. So as we pull data from S3 or your custom origin to our edge locations, and then also use encryption, HTTPS encryption, to deliver data to your end users on the internet. So let's go through. I'm going to have Matthew now go through some of the features in more detail about how we automatically use advanced SSL features in order to make that process both safe, secure, and performant.
We use Amazon CloudFront uses high security ciphers, and we enforce server cipher preference. So we have a list of ciphers that we have benchmarked, and we've determined that they perform very well, and they also provide you the good security. Well, what do we mean by the good security and the high security in the ciphers? We use ephemeral key exchange with our top priority cipher suites. And ephemeral key exchange simply means that the session key that is established to secure the one HTTPS session will not be reused to secure another session. And this enables perfect forward secrecy. Perfect forward secrecy is a property of a key agreement protocol that means that if the master keys or your public-private key pair that is your SSL certificate is compromised in the future, the key material cannot be used to go back in time and decrypt past sessions. And this is an excellent security feature of modern TLS cipher suites, and they are at the top of the CloudFront cipher preference list. On the right-hand side, you see a client hello, or SSL handshake, I should say. The client sends a hello. There's a server hello and a certificate. And we agree the key, the ephemeral key at this point in time. We finish the session, and then you have an SSL session established to CloudFront, so you can make your GET request securely. Improve performance. We do two things for you. We employ SSL, or TLS session tickets, I should say. And this allows us to abbreviate the SSL handshake. And we also support online certificate status protocol, or OCSP stapling for short. But what are session tickets? Well, if you remember our previous SSL handshake, at the end, when we've completed and agreed the cipher, the session and agreed the keys and the cipher we're going to use, we encrypt that data and we send it back to the client. This allows clients to reconnect in the future and abbreviate this handshake so you don't have the 2 round trips in order to establish SSL. As part of the client hello, the client would send a session ticket that he previously has saved. Amazon CloudFront is able to decrypt that as we have the keys to do that. And we can send back the session resumption and really shorten that TLS handshake. OCSP stapling. This is another TLS extension. And essentially what happens is the client sends a TLS client hello to CloudFront. And as part of the hello, they say that please provide the status of the certificate. CloudFront will request the certificate status from the OCSP responder and cache that response so that we can use it to send the status back to clients in the future. We send that back to the client, and at this point in time, the client now has, he can validate the signature in that OCSP response to determine that the server certificate that he is using has not been revoked, and give him confidence that that session is now secure. At this point, we have a SSL session from the client to CloudFront, and we can make our application level GET requests. So we did some testing. This is not from a browser. This is from some testing we did offline of our own. And we had a client-side application instrumented to record the various stages of the TLS handshake and doing OCSP checks on the client side. And in here, we can see we spent 50 milliseconds establishing a TCP connection. We sent the client hello, got the server hello back, and in that, we got the server certificate. The client then looks in the server certificate, he walks up the CA chain, and picks out the OCSP responder information embedded in the certificate. For each OCSP responder, for each certificate in the chain, he had to make a DNS query for that responder's domain name. He had to make a TCP connection to that service. He had to send a request and get a response. And here we took in excess of 250 milliseconds to establish a connection with CloudFront. We tried it again, but this time we said to the client sent the OCSP extension and said, hey, CloudFront, give me the certificate status for this server. We significantly improved the connection time. We still have the same TCP handshake up front. We still have the client hello and the server hello are approximately the same as before. But in that, as part of the handshake, the server responded with the OCSP response that validates the certificate chain. And we were able to complete the handshake a lot quicker without those intermediary CA checks. So in our test, we were over 120 milliseconds faster, which equates to about 30% for the time that we saw. The next thing that advanced SSL gives you is when CloudFront is establishing HTTPS with your origin, there are certain things that your origin certificate must hold up to. The first one is the origin domain name must match the subject name or a subject alternate name that's configured within that certificate. The certificate must be issued by a trusted CA. And a trusted CA to us, we use the Mozilla CA store, which is publicly available on the internet. And any reputable CA out there is included in that. And the last one, the certificate must be valid within the current time window, so the current date must not be past the expiration date of the certificate or before the start date of the certificate. I'm going to hand back now to Alex, and he's going to tell you about what you need to do in order to secure your services.
Yep. Thanks, Matthew. So up to now, we've been looking at things that were kind of in the DNA, if you remember the logo from the beginning, side of the equation. We're going to shift now to things that you need to do as a developer, either in your configuration of CloudFront or as you build your application. Delivering content using HTTPS, there's two options. By default, a CloudFront distribution will accept connections either on an HTTP or an HTTPS connections. Many of our customers want to use only HTTPS. And to support that, there are two options you can configure in CloudFront. The first is strict HTTPS, and this is just a setting on your distribution that says, do not accept connections that come in over an HTTP connection. The second one, which we're seeing more and more customers use, is actually to redirect customers from the HTTP version of an asset to the HTTPS version of an asset. So this is a configuration you can make as part of your CloudFront distribution configuration in order to say, I want to use strict HTTPS, or I want to redirect HTTP to HTTPS. If you do nothing, your distribution will accept both. There are different options that we support for, say, SSL to a TLS is more technically accurate. A lot of these have to do with what kind of cert you're going to use. The first option is to use the CloudFront domain name and the default CloudFront.net cert. And this is one certificate. It's a wildcard certificate for star.cloudfront.net that are shared among many customers. And so you see an example down at the bottom, the DXX, where XXX is the unique identifier for your distribution, .cloudfront.net. The second option is, and this is a simple option, CloudFront.net works well for many use cases. It's not very customer friendly, though. We don't see a lot of customers or end users who want to type D123456 into a browser. So in addition to offering the CloudFront.net certificate, we have two other options that both allow you to bring your own SSL certificate. The first is SNI-based custom SSL. And this relies on the SNI, or server name indication, extension to the TLS protocol. And so it will allow you to upload your certificate into the identity and access management system. And it allows you to put your own certificate up there. The SNI extension sends the host name outside of the SSL handshake. So we know which cert to use. We say, hey, we're getting a request for www.mysite.com. Let me go get the cert for www.mysite.com. The good news about SNI-based custom SSL is we provide it free of charge. The bad news is that it's not supported 100%, and particularly some older browsers or browser OS combinations don't support the SNI extension. So we have a third option that is universally applicable that allows you to bring your own SSL certificate, and we will dedicate IP space to your certificate at each of our edge locations. So in that, we get a request for 1.2.3.4, where that's the IP address of a particular edge location that falls into the IP space we've dedicated for your SSL certificate. We use that to select the certificate. The good news is that works on 100% of browsers. It is an extra fee that we charge to reflect the IP space that is being consumed by that. Before I go back, there's an additional option. We had a question somebody asked about the Poodle vulnerability. There's an additional setting for dedicated IP-based custom SSL, which is to set the minimal protocol version that you want to support. We recommend that you set that to support only TLS 1.0 or higher. Some customers have applications that are trying to reach older devices that maybe only do SSL v3. So as an option, you can go in and say, I want to allow SSL v3 connections. That has some exposes some vulnerabilities that came out with Poodle or Heartbleed?
Poodle.
Poodle, sorry, I got it mixed up. But it gives you flexibility if you do have older clients that need to reach only support SSL v3. I want to talk a little bit about a customer example and some of the different ways that the customer has used different configurations for SSL on CloudFront. The customer is MapBox, and what they wanted to do is to use a custom domain, so xxx.mapbox.com. They knew their clients supported TLS, so they were delivering primarily to applications that ran on known clients, so they wanted an economical option. They opted for SNI-based SSL. There's a couple of usage patterns, and MapBox actually used both. The first is what I'll call half-bridge TLS termination, and the second one is called full-bridge TLS termination. So what do I mean by that? Half-bridge termination basically does the HTTPS or the SSL TLS session only between the edge location and the end user. And data back to your origin is sent over a regular HTTP connection. Why would you want to do this? Well, this is useful for getting content that is not inherently secure. So for example, the MapBox logo that might be contained within a page that has other information that is secure. So you want the entire viewer, the customer end user session to be secured using HTTPS, but there's no reason to secure the MapBox logo on the origin side. So that's OK to run over an HTTP session. And you can create a property of your CloudFront distribution, and it's actually a path pattern. It's a feature we call cache behaviors. So you say anything in half-bridge, I'll make that up. I want to use a HTTP connection back to the origin. Anything else, I want to use an HTTPS connection back to the origin. So you use half-bridge when the content you're trying to secure is not inherently not inherently sensitive, but is part of a broader package that requires encryption. Full bridge TLS termination, this is more common. What this does, it says I want to use TLS all the way. So both between the end user and CloudFront and the origin. And so the way to do this is you would configure one of the two options I discussed earlier, either to enforce HTTPS from the CloudFront distribution to the end user, or to redirect, and then set the CloudFront cache behavior to match the viewer. That basically says I'm going to go to the origin using the same protocol that I had from the viewer. Because I've limited the traffic from the viewer to only come in over HTTPS, I know I will only go to the origin using HTTPS. I kind of alluded to this. MapBox uses multiple origins. For the content that is not inherently secure in and of itself, they use the half-bridge model. And for most of the other content, they use the full-bridge model. But you're not done yet. So now we're going to go into some other options for securing, particularly for protecting content that is cached at the edge. This is a feature that we think of as terms of access control. So it's not encryption, but it's controlling who is allowed to access your content. And so this can be useful if you're trying to, say, run deliver content only to selected customers, have an expiration period where I only want this URL to be valid, or trying to limit the IP space to which you can deliver your content. So we have two solutions for this that each work in similar fashions, but if different, can be implemented in two different ways. So the general feature is something we call private content. And what private content says is I'm going to create as a developer a policy that says this is when I want this URL to be valid. I'm going to include in this policy a time range, an IP range, and the name of my assets or a path pattern. I'm going to sign that with a private key that I have. Amazon CloudFront is going to have the public key half. When we get the request, we're going to decrypt the signature, look at the policy file, and then only serve the content when the policy is valid. There's two different ways to implement this. The first is an assigned URL. So in assigned URL, you attach that signature into a query string, and your URL changes. So I'll have a web server that is producing unique URLs for each user. If the user is entitled to the piece of content, I'll put my essentially entitlement server will put a valid signature onto the URL, send it out, and the object will be downloaded or the video will play. If not, it won't. And so that way you have control as to who's able to download content from your CloudFront distribution. Works really well for restricting access to individual files. We also have a version of this that works with our RTMP streaming distributions. But the world has moved to, in the video space, fragmented video, things like HLS, MPEG-Dash, HDS Smooth. There's a bunch of these fragmented video files which contain a manifest that references individual video fragments. So we started to hear from customers that the idea of signing each line in that manifest, where each line represents a particular video fragment, was pretty onerous and was adding to extra work for their web servers. So rather than doing that, we implemented another option that we call signed cookies. Signed cookies take all that same logic for developing a policy file and puts it into a cookie. And so that allows you to restrict access to multiple files without changing URLs. Very useful for this fragmented video, and then we've found that customers are actually using this in other areas, other use cases that we didn't necessarily expect. So here's an example of a policy statement for URLs. You'll see the resource line. That's where you specify the URL. You can include a asterisk. You can include a path saying, hey, I want to include everything that matches this pattern. Condition includes a date. So basically, we will enforce that the date is less than a particular point in time. So you might have your web server say, I only want this URL to be valid for 24 hours, or I want it to expire at midnight on the 15th of the month. And then the last one is the IP address. You can actually use CIDR notation here to say the range of IP addresses from which I want this video or this asset or this image or this JavaScript file, whatever it is, who's allowed to access it. So the IP address, all of these are optional. You can use 1, 2, 3 of these in combination with one another, and then include it in your policy file. So one of the ways customers use this is kind of as a development mode. So we'll see customers initially restrict access to their CloudFront content using an internal IP address range. And this allows you to test things before you make your site widely available to the public. But you're still not done. So what if you want to restrict access based on the parameters in the request? So up to now, we've been talking about things that you do on the web server side. There may be requests that are valid and other requests that you consider unnecessary. And so this example talks about scraper bots. There are other examples where you may say, hey, this traffic is not what I want hitting my distribution. So in order to solve for that, we launched just this week AWS WAF. And what AWS WAF does is it allows you to block or allow content based on characteristics of the HTTP request. So Matthew, this is an example of, sorry, I missed a slide. MapBox, using the example, has been using a beta version of AWS WAF. And what they've done is they've built a sort of closed loop where they start with logs coming off of the server logs. And they use this to do some threat analysis. They then use the AWS WAF API in order to update their rules, which determines what traffic is valid, what traffic is not valid, what do they allow into their CloudFront distribution. So with that, Matthew's going to give you a quick demo of how you can use AWS WAF to block bad bots dynamically using web ACLs.
Sure. So I'll take you through the technical implementation of a website we put together, which is served on CloudFront and integrates with the AWS WAF to demonstrate some of its features. So the example we're going to use is blocking bad bots dynamically with AWS WAF, web ACLs. We need 3 things to get started. We need an IP set. This is a AWS WAF condition, and we basically say we'll populate this with the IP addresses of our bad bots that we dynamically detect. The next thing we need is a rule. And this tells us what to do when requests match our condition or are contained in our IP set. And our rule is going to be to deny. And then we create a web ACL, which is a collection of rules, and an associated default action, which is allow, so that the non-bad bots are still able to access our website, unless it matches our rule, in which case they'll be denied. And then our web application needs 2 things. The first thing is a mechanism to detect our bad bots. And then we need to be able to take what we detected and update our web ACLs so that they're propagated to the edge. So the first part, detecting bad bots. We did this relatively simply. We created a robots.txt file which says disallow /honeypot. So any good and well-behaving bots like the Google bot, the Bing bot, etc., will download the robots.txt and will not index pages starting with matching /honeypot. We uploaded that to the root of our web application. And then the second thing we did was to create a hidden link within the page, which protects us against scraper bots who are downloading the HTML, scraping it, and following the links to get all your content. It's hidden so that a regular user of your website will not see it and won't be tempted to click on it. And once that URL is requested, it triggers an action, which is how we block our bad bots. So when the honeypot link is requested, we generate a change token for the AWS WAF that allows us to update our IP set. We take the IP address of the client that connected to CloudFront and insert it into our IP set. That change is saved and propagated to the CloudFront edge locations, typically in under 1 to 2 minutes. Pardon me. So I'm going to give you a quick demonstration of this in action. So here's our website, our quacky nature, offering the largest selection of rubber ducks to the internet. So here we have our bad bot trapping, which we click on this link and it tells us a little about what we just talked about. And we're going to hit test. OK, so our origin has returned blocked, and it's added our IP address 208.78.232.1 to the IP set. So hopefully now, when we go back to quackynature.com, our request cannot be satisfied. The AWS WAF has blocked our request, and we're no longer able to access that page or any other page on our website that's protected by that web ACL. So I'm going to hand back to Alex.
Cool. I'm going to take a couple of additional things to think about just in terms of as further securing your CloudFront distribution. Cloud Trail, we talked earlier about sort of the importance of logging. Cloud Trail is great for recording a full history of who is making changes to your AWS resources in general and CloudFront in particular. So what Cloud Trail does is it looks for the CloudFront API calls, so not the data plane calls, but the control plane calls where you create a new distribution or delete a distribution or modify it. Really useful for understanding who's made which change to your CloudFront configuration. Application security. So let's go just one level higher up and talk about how you can secure your application and your origin. The things in this category are things around IAM, they're things around origin access identities and key management. We'll talk about each of those. So no matter how secure you make CloudFront, if your origin is accessible, a malicious party could go around CloudFront and access your origin. So we offer two different ways to restrict access to your origin. They're different whether they're S3 or what we call custom origins. Custom origins actually include things that are running in EC2 or ELB. So it's not AWS versus non-AWS. It's just S3 versus everything else. Origin access identity is the technique we use for securing access to your S3 bucket. And basically what this is it is a very limited purpose identity that CloudFront uses to access your S3 bucket. You can create either allow it to access specific objects or more commonly an entire bucket. But it makes sure that you have control over what CloudFront is using. So we're essentially going to go to that S3 bucket using this identity. And that way you can ACL individual objects or buckets just to CloudFront, just to us. It's not shared with any other customer. It's just a unique, very limited purpose identity that CloudFront uses for a particular distribution. For custom origins, the approach that we use is whitelisting of the recommend using is whitelisting of the CloudFront IP range. So this ensures that your origin doesn't get overloaded from requests that don't originate from CloudFront. And I guess we talked about this, but here's a little diagram where a customer comes in, they try to access, this is at the bottom, or I guess in the center, your CloudFront distribution. The portion of your site that's hosted in S3 is validated using that limited purpose origin access identity. If somebody comes in and tries to access your S3 bucket, that S3 bucket is not going to allow content to be served or the object to be served by anonymous users, so that doesn't work. For custom origins, the way the approach works is it limits access based on IP range. So CloudFront IP space is going to be whitelisted for your custom origin. A malicious user trying to access your origin from outside of the CloudFront IP space will be denied. So how do you know what the CloudFront IP space is? Well, what we do is we have a Amazon SNS notification that automatically provides notifications on changes to that IP space. And you can use this to automatically update security groups. If you stick around for the next session, it's actually in this room right after this, we're going to demonstrate a Lambda function that one of the engineers on the CloudFront team has written that will consume those SNS messages and automatically configure a security group to add new IP spaces or to CloudFront's changing IP space. So you can stick around and see that in the very next session. Identity access management, again, this is more of an AWS sort of fundamental, but this allows you to create managed policies or custom policies that control who and how users are able to interact with the CloudFront APIs. So this is user roles and permissions. Again, not going to go super deep here because this is more of a Amazon general kind of thing. But a couple of the things that we see customers do in practice, CloudFront has an invalidation API. And invalidation lets customers remove objects from cache prematurely, if you will. You can basically say, hey, this object has not reached its expiration, but it's a bad image, or there's something else wrong with it. I want to get it out of cache everywhere. In many organizations, the user who may need to do that doesn't need full privileges to create and modify CloudFront distributions. So we see customers using IAM in order to give one group of users just the ability to create invalidations and not actually modify the core configuration of your CloudFront assets. The second one is probably more common, where we see customers who want to give essentially read-only privileges, so give someone the right to review configuration data but not actually make changes. So that's, again, possible with IAM. So the last thing, how do you validate all of this? This goes back a little bit more to SSL, but SSL Labs has a tool that will look at various settings as part of your SSL configuration. And if you do all of the stuff we've talked about, you can actually get a A+ rating on SSL Labs. Again, a little pitch for our next session. We'll go into more detail here in the next session. But this goes to show that if you apply these things, you can actually lead to a much more secure delivery platform. So with that, thank you. I hope that you've learned some tactical things. I will stick around. Matthew will stick around up at the front of the room. We'd be happy to answer any questions. We appreciate your time. And please stick around for the next session. We'll be doing a series of 4 quick talks from engineers, very practical in terms of takeaways you can have to make your content faster and more secure. Thank you.